Question number 9F. We have this fourth degree function and it's got a negative leading coefficient, so it's got to be opening down, so it's got to be like that. And we have it in non-factored form. So we have to factor this. So we're going to first start off by identifying the possible roots and then apply the remainder theorem to see which ones work. And we need to be able to guess two of them so that we can break it down into the quadratic function from which we can factor. So I'm going to start off with the easiest one. So I'm going to start off with 1. So I'm going to use my remainder theorem. When x is 1, I get negative 1 minus 2 plus 3 plus 4 minus 4. So that is 0, so that is a factor. So one of my factors then is going to be x minus 1. So I should test maybe negative 1. If I test negative 1, I end up with, this is going to be negative 1. This will be plus 2 plus 3. This will end up being negative 4, negative 4. And I don't really care what it's equal to. I just know it's not equal to 0. So this is not a factor. So I'm going to move on to my f of 2. Substituting into the equation, I get negative 16 minus 16. This is going to be plus 12 plus 8 minus 4. And again, we just know that that's not equal to 0. So that is not a solution. That's not a possible root. So then we go on to negative 2. And in this case, I end up with negative 16. This becomes positive 16 plus 12. This works out to be minus 8 minus 4. And when I sum that all up, that is equal to 0. So I've now found two roots. So I have two factors. That's all I need at this point. Now I can break down my polynomial to be able to find the quadratic, and then I can factor that quadratic. So setting up my division here, I have negative 1, negative 2, positive 3, 4, and negative 4. Okay, and I'm going to divide in my two factors that I've already solved for. So I just need a little bit of space here to do this. So I'm going to start with my negative 1. So I end up with 0. Okay, so this is my remainder 0. Again, if I don't get remainder 0, I've done something wrong, because that means that it doesn't divide evenly, so that means that these could not possibly be factors if that's the case. So again, bring down my negative 1. I end up with, in this case, negative 2, so 3 minus negative 2 is negative 1. That's going to be negative 2, so it's going to be positive 2. So again, I get a remainder of 0. That's what I'm looking for. So my remaining quadratic is negative x squared minus x plus 2. So this is what my function looks like so far. It's f of x is equal to x minus 1, x plus 2, and then I have this negative x squared minus x plus 2. So I'm going to factor the negative out, so I end up with negative. And then my quadratic factor looks like this. So plus 1 minus 2. So this factors into plus 2 minus 1. So it actually repeats those same factors. So we end up with x plus 2, x minus 1. That means we have a multiplicity of 2 for both of those. So x minus 1 squared, x plus 2 squared. So that's going to give us roots at, and I'm going to scale the axis here, so I'm going to make that +1. This is going to be -2, so I have my points there. I know the direction of opening. I should also graph the intercept. So when x is 0, I plug in 0, I get 1 times 4. That's going to be 4, and then it's going to be -4. So -4 I'll show here. Okay, and then so this is going to be, since these have multiplicities of 2, they're going to be balances, and it has to be upside down. It's going to be some graph that looks something like this. And it's going to bounce twice at the x-axis and be facing down. Okay, now you might draw it slightly differently, but again, the key points that I'm looking for are these two intercepts and that there are bounces there, and then you have to also show a y-intercept and the direction of opening.